here from helpmegraduate.com. Like I said before, we're going to increase the pace and the difficulty of the examples, okay? The past couple of examples were a little bit easier, and the second one was a little bit harder, and this one is going to be a little bit harder, okay, more difficult. Again, it's all about seeing the notable limit in the expression that we have, okay, and using the properties of trigonometric functions. In this case, we have the sin of an addition, okay, and as you may have recalled, sin of x plus h is going to equal sin of x times cos of h plus sin of h times cos of x. So we're going to expand that expression and make it look like this, okay? Because that will likely get me somewhere into the simplification process. So let's move this around here. And first of all, we evaluate. What happens when h tends to 0? Whoa! Remember, note that in this case, h is the variable. It's not x, okay? In this case, the variable is h. So I have to get rid of the indetermination regarding h, okay? So when h tends to 0, on top I'm going to have, well, h is 0, so sin of x minus sin of x is 0. And at the bottom I'm going to have 0. So I have 0 over 0 indetermination. So I have to work on it, okay? So I'm going to expand the sin of an addition and make it look like that. So I'm going to have limit when h tends to 0 of the following: sin of x times cos of h plus sin of h times cos of x. Alright, this is just expanding the sin of an addition. This is equivalent to this, okay? And then minus sin x, minus sin of x over h. Okay, I just expanded. Now, how does that help? Well, let's see if I can get somehow this to appear. In this case, h is the variable, so I know that I have to work on the fact that I have to obtain sin of h over h. Well, I have one right here, and you probably see it right here, okay? I have one here. That's good. But I also need one to show up with the other two parts of the equations, okay? So that's what I have to kind of work on, okay? So let's do that. Let's move this a little bit to the left, and we're going to put these two together because, as you can see, they share a common factor, sin of x, okay? And we're going to break those two into something more familiar, okay? So this is equal to limit when h tends to 0. Again, I'm moving this to the left. Sin of h cos of x over h. And I'm left with these two. Okay? Plus sin of x cos of h minus sin of x over h. Again, all I did was broke the previous expression into two pieces. One that has the notable limit, which I know, and one that doesn't, which is right here. Okay? So what I'm going to do next is do a common factor on this, which is sin of x. Okay? Sin of x is common factor for these two members. So I'm going to rewrite this, okay, as sin of x, common factor of cos minus 1, okay? And this looks a little bit, it looks a little bit kind of, I've seen this expression before. Well, indeed we have, because remember the following, okay? In the past example we used 1 equals sin square of h plus cos square of h. And that means that sin square of h equals 1 minus cos square of h. So this is where we want to get, okay, because we want sin to appear here, okay? So I'm going to extract minus 1 common factor right here, and minus times plus is minus, so this is going to end up like a minus. And I'm just going to rearrange this expression to look like this. Since I have minus 1 as a common factor, it ends up looking like 1 minus cos of h. Okay, all I did was a common factor minus 1, so that's why I have the minus sign right here instead of the plus. And I just rearranged the expression because minus 1 is a common factor. Okay? There we go. So, if I want sin to appear here, well, it would be great if I could get to here. Okay, so that means, well, I have to do the multiplication of the conjugate. Okay? Why? Because x minus a times x plus a equals x squared minus a squared. So in this case, I have this and I'm missing this. I have this and I'm missing this. In this case, this is going to act as x and this is going to act as a. So all I have to do is the multiplication of the conjugate of this, which is 1 plus cos of h over 1 plus cos of h. Okay? So when I multiply this times this, again, this times this is equal to, say, this times this. So I'm going to square 1 minus cos square of h. Okay, again, 1 square minus cos square of h. Okay, and that's it. I'm going to rewrite this, and this goes at the bottom right here, multiply. I can't simplify it anymore. So I'm going to rewrite this as h that multiplies 1 plus cos of h, and on top I'm going to have 1 square is 1 and cos square, and there you go. X and a using this property after you multiply with the conjugate, okay? But since I have this right here, I can rewrite this as sin square, okay, of h, because h is the argument. So I erase this, and I rewrite this as sin square of h. And there we go. I'm able to obtain this. Why? Because I can rewrite this as, I can rewrite sin square of h as sin of h times sin of h. I'm just breaking it into two pieces. And here we have the notable limit. This is equal to 1, and this is equal to 1. And now I got rid of the indetermination on both sides of the function, okay? So since this is 1, I can just get rid of it, okay? I can just erase it because it's 1. 1 times whatever is whatever, or whatever times 1 is whatever, okay? So, just a few seconds so you can get a glance of it. 1, I'm going to get rid of it, and 1 right here, I'm going to get rid of it. So I erase, and I erase. Isn't it wonderful when you get rid of the weird stuff? Just going to put this at the bottom right here. There you go. So now I evaluate because I got rid of the indetermination. When h tends to 0, well, cos of x stays the same because there's no h here. Cos of x stays the same, okay? And when h tends to 0, well, sin of h is 0, so I have 0 times sin of x, and that's 0. 0 times whatever is 0. And this is 0 right here. And at the bottom, I'm going to have cos of h. Cos of h is 1. 1 plus 1, 2. So I'm going to have 0 over 2. And 0 over 2 is 0. So this whole expression is 0. It's gone. And all I'm going to have left is cos of x. So the answer of the exercise is cos of x. Okay? That's it. Beautiful. A little bit difficult? Yes. A little bit creative? Yes. Required a lot of knowledge of previous properties? Yes. As you can see, we used 1, 2, 3, 4, 5 properties. Okay? You just have to combine them, practice, keep practicing, and do them over and over again. Again, be careful with this part because this is where we kind of became tricky. All we did was rearrange the expression so that we could separate and break them into parts that had the notable limit and parts that didn't. Then the part that didn't, we did the conjugate and the identity trigonometric property to make it look like that. We got rid of it. All of this equals 0, and then all that's left. When h tends to 0, cos of x stays the same. Okay? So this is the solution to the exercise. See you in the next video. It's going to be a little bit harder, a lot similar to this, but a little bit harder. Okay? Take care.